Welcome back to math class. We're going to keep talking about compound probability. So this is part 2. You should have watched the part 1 video already and taken those notes. We are going to just continue on and add to those notes, making one nice, beautiful pile of notes talking about compound probability. So yesterday, or whenever you watched that lesson, the last lesson we talked about ways of staying organized with a compound event, like rolling 2 dice or flipping 2 coins. And we talked about table method, tree method, list method. Okay, so we're going to keep cruising with that thought. All right, so think about this problem. You pick a card at random, you put it back, and then you pick another card. So I can close my eyes, I pull a 3, I put it back, I close my eyes, I pick a 5, put it back, like that. So I could still make a table, a list, or a tree diagram to explain this. But what if I didn't need to know exactly what each combination was, but I still want to know how many possible outcomes there were? Is there an easier way? It turns out that there is an easier way to figure this out. If I don't need all the details and I just want to know how many possible outcomes there are, I can multiply the number of different outcomes together. So I know on the first card I can get a 2, 3, 4, or 5. That's 4 different things. And then I put it back, and then when I reach in again to pick a card, I could get a 2, 3, 4, or 5. So that's 4 different things. So there's 4 possible outcomes on the first pick, 4 on the second. I multiply them together, and I can find out that there is 16 possible outcomes here. So let's add that to your notes. Again, this is not a new entry. This is continuing on yesterday's notes with the table, tree, and list method. So hit pause and add this right underneath where you left off on the last time. Okay, so we're going to call it the fraction method for number of outcomes, and we're just going to multiply the number of outcomes for each event together. And then if you haven't already, copy this down. How many sandwich combos can be made with 2 types of bread, 3 cheeses, and 4 meats? Okay, so all we're going to do is go the number of possibilities for bread times the number of possibilities for cheeses times the number of possibilities for meat. And then I get 2 times 3 is 6. 6 times 4 is 24. There are 24 possible outcomes here. Again, this does not give me all the details about like how many sandwiches have cheese, what cheddar on them or whatever, but this just tells me how many possible sandwiches that there could be. All right, so grab your whiteboard or your scratch paper and I want you to give it a try. Claire is designing a web page. There's 3 background colors and 4 fonts to choose from. How many different designs can she create? Hit pause, try it out. It's easier than you think. Hopefully you got that and saw that 3 backgrounds times 4 fonts gives us 12 possibilities. Okay, I'm going to have you read these yourself and try them yourself and come up with 2 answers. Hit pause and then compare them to mine when you're ready. Let's see how you did. By the way, you might recognize this as looking like it could be an IXL exercise. Even more reason to really play along on these, and that way you're actually ready to do the IXLs when they are assigned to you. Okay, so 10 meats times 2 different kinds of cheese, we get 20 different kinds of sandwiches there. Kamal is the king of trail mixes. He's got 5 nuts times 3 dried fruits times 2 types of cereal times 3 kinds of candies. So that is 90 possible trail mixes that can be made. And again, we're just multiplying the number of outcomes together. All right, so what if instead of wanting to know just the number of outcomes, I want to know a specific probability? There's a little shortcut for that too. So I'm just going to multiply the probabilities of each event together. So what if I want to know the probability of rolling a 3 and a 2? Okay. So I'm just going to look at the probability of rolling a 3 and the probability of rolling a 2. Oh, isn't that funny? I got them flip-flop there. But what are the chances of rolling a 3? There's 1 3 out of 6 possible sides of, oh, come on, let me write there. 6 possible sides. With 2, there's 1 2 out of 6 possible sides. So the probability of rolling a 3 and a 2, if you're rolling 2 dice at the same time, is 1 6 times 1 6. And remember, when you multiply fractions, you just multiply across the top and multiply across the bottom, and we find that you have a 1 in 36 chance of rolling a 3 and a 2. Okay, so hit pause, copy that into your notes. So the fraction method for probability is to find the probability of each individual event and multiply them together. So hit pause, copy this down, and then we'll get some examples in those notes. All right, probability of on rolling a dice of rolling a 4 and then rolling a 1. Okay, probability of getting a 4 is there's 1 4 out of 6 total. Probability of getting a 1 is there's 1 1 out of 6 total. And we multiply those together and we find there is a 1 in 36 chance of first rolling a 4 and then rolling a 1. All right, probability of getting 2 2s. So how many sides are 2? 1 out of 6. How many sides are 2? 1 out of 6. And then there we get it together. Now some people think like, oh, like doubles are lucky or they're harder to get. But your chance of getting a 2 and then another 2 is the same as getting a 4 and then a 1. So there you go. All right, let's make this a little bit trickier. Probability of getting a 3 and then getting greater than 3. Okay? Probability of getting a 3 on a dice, there's one side that's a 3 out of 6 sides total. Probability of greater than 3, let's think about that. What's greater than 3? 4, 5, and 6 on the die are greater than 3. So that's actually 3 out of 6, or 1/2. And then you multiply those together and you get 3 out of 36, which simplifies down to 1 out of 12. So you have a 1 in 12 chance of getting a 3 and then a number greater than 3 on the dice. So hit pause if you need to, if you couldn't keep up, and make sure you have those examples completed there. Okay, grab that whiteboard or that scratch paper. I want you to find the probability on my little spinner here of spinning a blue and then spinning a red. So remember, find those fractions, multiply them together. Hit pause and then play again when you're ready to go. All right, how did you do? Probability of getting a blue, I know it doesn't look completely blue, but I hope you figured that out, is a 1 in 4 times the probability of getting a red, which is a 1 in 4. And you multiply those together and you get a 1 in 16 chance. Okay, so I want you to hit pause and I want you to, again, keep going with these, see how you do, and you can compare in a minute. Don't cheat, hit pause. All right, let's see how you did. Probability of blue is 1 in 4. Any color not red, there's 3 out of 4 that are not red, and you multiply them together and simplify, and you get 1/4. Probability of a red or a blue, well, 2 sides are red and blue. 2 sides are green or orange, and you multiply those together, and you get 4/16. If you did 1/2 times 1/2, then that takes you automatically right there. So it doesn't matter if you simplify here or you simplify at the end, you should still have gotten 1/4 as your final answer. Okay, let's try a couple more. So let's like reach into this little bag of letters here and pull some tiles, like you're playing Scrabble or something. You're going to put them back afterwards. So it's like reaching in, pulling out an A, putting it back, reaching in, and pulling out an A again. What are the chances of that? So I'm going to have you try all 3 of these. And, just kidding, all 4. Let's see if you can get all 4. Vowels are, I'm going to give you a little help there, in case you don't know. Vowels are A, E, I, O, U. Sometimes Y, but we're not going to count Y here. And then consonants are all the others. I'm just going to write others to remind you. Okay, hit pause, don't cheat. Try these 4 and see how you do. Let's see how it went for you. Probability of getting an A is 1/7. Probability of A again is 1/7. You multiply them, you get 1 out of 49. Probability of S or A. So how many S's or A's are there? There's 2. Probability of T is 1 out of 7. You multiply those and you get 2 out of 49. How many tiles are consonants? 5 of them are consonants right there. And there are 2 vowels. So we have 5 sevens times 2 sevens, which gives us 10 over 49. And any letter that's not a G, that's 6 out of 7 of them. Or a G is 1 out of 7. And we multiply that together and we get 6 out of 49. Hopefully you're killing it. If not, take a look and figure out where your mistakes are coming from, and make sure you review your notes and your examples in your notes. Okay, one last situation talking about compound probability here. What about a problem like this? So I'm going to pick a card at random, and without putting the first card back, I'm going to pick a second card at random. Okay? So I'm not going to throw it back like I have on every other example so far today. I'm going to pick it, keep it, and then I'm going to reach in again. So we're going to look at the probability of getting an even number and then picking an odd number. All right, well, it's all going to start the same. So what's the probability of getting an even? I have 2 evens out of 4 cards altogether. So the first time I reach in and I pick, I'm going to have a 2 in 4 chance of getting an even. Okay, now here's where it gets a little complicated. So I have one of these cards in my hand. Okay, one of them's gone. I don't know which one's gone, but now I know that there's 3 cards gone. There's only 3 cards left to pick from. So what's the probability of getting an odd? So of my cards that are left, how many of them are odd? And so remember, I pulled an even before. I don't know if I pulled the 6 or the 8. It doesn't really matter. Okay, but just like imagine knocking one of them out. And then now I have 3 cards left. How many of them are odd? 2 out of 3 of them are odd. Blech. Okay, I multiply these together. I get 2 times 2 is 4. 4 times 3 is 12, and then that simplifies down to 1/3. So I have a 1/3 chance of picking an even, not putting it back, reaching in, and getting an odd out of what's left. So situations like this are called dependent events because the probability of the second event depends on what happens in the first event. So the first event decreased my number of cards, and so that changed my probability for the second event. So go ahead and hit pause and copy the definition of a dependent event into your notes. All right, so again, that's where the first event affects the outcome of later events. And the example is pulling a card and not putting it back. That's an example of a dependent event. All right, let's get some examples in our notes. So hit pause, copy this down, and then hit play again when we're ready to work it out. So bag has 3 blue, 2 red, and 5 green marbles. After pulling a marble, we're not putting it back. Okay, we're not putting it back. We're holding on to it. So let's see what we can do here. So go ahead and pause and write down these 2 situations, and then hit play again when we're ready to work them out. Okay, the probability of getting a blue, not putting it back, and then getting a green. Okay. All right, so let's see, how many total marbles are we talking about here? So we have 3 plus 2 plus 5. We have 10 marbles total. So the probability of getting a blue is going to be out of 10. Okay, 3 of them are blue, so we have a 3 in 10 chance of pulling a blue marble. Okay, so now we're going to hold on to that blue marble. So we have a blue marble in our hand, and let's imagine what is left. Okay, do we have 10 marbles anymore? No, as a matter of fact, we are all losing our marbles here. We are down to 9 marbles, okay? And of those 9 remaining marbles, how many of them are green? We have 5 green marbles, okay? There we go. And now we're going to multiply like we did before. So 5 times 3 is 15. 10 times 9 is 90. We could also do some cross-canceling there. Or we could simplify, but either way we can end up dividing by everything by 5, or actually dividing everything by 15 here, and it simplifies down to 1/6 is our final answer. All right, let's try another one for our notes. What's the probability of pulling a red marble and then pulling another red marble? And again, we're not putting that first red marble back. Okay, so probability of getting a red, that starts out pretty easy. There's 2 reds, there's 10 marbles. We're starting fresh here. We're not like, we put those blue and greens back when we start a new problem. Okay, so 2 out of the 10 marbles are red. Okay, all right, when we reach back into that bag now, there are not 10 marbles anymore. Now there's only 9. And there's not 2 reds anymore, are there? Because we have one of them in our hand. So we're actually down to 1 red, like that. And when we multiply them together, we get 2 out of 90. Which simplifies down to 1 in 45. So not very good odds of pulling a red, holding on to it, and then getting that second red. Hit pause if you need to. Fill that in. Okay, grab your whiteboard or scratch paper, and I want you to give it a try. You're going to reach in, you're going to pick a card, and you're not going to put it back. So what's the probability of getting a 7 on your first try? So write down some kind of fraction for probability of 7. And then write down a fraction for picking a number less than 7. And remember, you are not putting that first card back, so your denominator is going to change. Hit pause, make it happen. Hey, how'd you do? So probability of getting a 7, that's easy. That's a 1 in 3 chance. Picking a number less than 7, so pretend the 7's gone. We have 2 cards left, and they're both less than 7. So that's 2 over 2. You multiply, you simplify, you get 1/3. Let's try another. So hit pause, read over the situation, and then be ready to compare yours to mine. And again, I hope you're actually practicing these because, hey, this looks like IXL now, doesn't it? And you're going to be asked to do this later on in the week. Okay, so probability of getting a 3, you have a 1 in 4 chance of getting a 3. And then picking an odd number. So imagine that card is gone now, so we only have 3 remaining cards, and only one of them is odd. So you just have a 1 in 3 chance for that second one. You multiply, and you end up with 1/12. Okay, again, I'm going to have you try 2 problems in a row with the spinner. Okay, so this is spinning the spinner twice. You don't like rip part of the spinner off. So we're not going to do a dependent event anymore. This is just kind of like review from before. And flipping a coin twice. Again, this is not a dependent event. This is like more from the beginning of the lesson. So just seeing if you can switch gears and go back to those types. So hit pause, try these 2 situations, and then you can see if you got them right. All right, probability of landing on a 5 is 1 out of 3. Probability of landing on an odd is still only 1 out of 3. So again, that piece of spinner is still there. You don't get mad, rip it off, and throw it away. You multiply them and you get 1/9. Flipping the coin, probability of getting tails is 1 out of 2 sides. Probability of getting another tails is 1 out of 2 sides. And so you actually have a 1 in 4 chance of getting tails and then getting tails again. Okay, 2 more. Again, this is a classic probability, and then this one is a without putting the card back dependent probability. Let's see if you can switch back and forth between the 2. Make it happen. Hit pause and don't cheat. All right, so how did you do? This top one was pretty easy. Probability of getting an even, 2 of them are even. And then probability of getting a 6, 1 of them is 6. So 2/4 times 1/4 is 2/16 or 1/8. This one was a little trickier. Okay, probability of pulling an even. There's only one even, it's the 6. So we have a 1 in 3 chance of getting an even. And then remember, you're not putting it back, you're holding on to it. So if you reach back in, oh, I made a mistake there. That bottom number should be 2, not 3. But either way, it doesn't matter. There's no evens left. So when you multiply them together, you get a 0 out of 6 chance, which ends up being 0. So it's impossible to pull an even, hold it in your hand, and get another even. So remember, in probability, 0 means impossible. All right, let's circle all the way back around to the beginning of the lesson yesterday with that duck problem. The little sister at the carnival trying to win the sock monkey. So she can win the sock monkey if she pulls 2 ducks that both have a 1 on the bottom. So she's going to pick up the duck and find one with a 1. She's going to set it to the side. She's going to reach in again and find the other one. So this is actually a dependent event. So what's the probability of getting a duck with a 1 on it? Okay, well, there's 2 ducks with 1s out of 12 ducks altogether. So pulling that first one, she has a 2 in 12 chance, which, you know, isn't great, but it's not horrible either. All right, so now she reaches back in. There are no longer 12 ducks. There's 11. There's no longer 2 1s. There's only 1. So that's 1 out of 11 like that. And when you multiply them together, you get a 2 on top. I don't know what 12 times 11 is memorized. What kind of math teacher am I, huh? It's 132. I divide both those by 2 because they're even, and I get 1 over 66. So that's not good chances, right? A 1 in 66 chance of winning that sock monkey, and your sister's throwing a fit. She won't leave till she has a sock monkey. Guess what, sister? You're going to have to cry all the way home because I don't think you're winning that sock monkey today. Keep that in mind next time, you know, like someday when fairs open again and you can play carnival games, that, you know, your chances might not be as good as you think, and you might be better off just buying a sock monkey for the amount of money that you spend trying to win one. Okay, well, we are going to do the summary now. I want you to think back. There's going to be a video after this, so you can hang out after your summary and watch the video if you'd like. Or when you're done with your summary, you can just end. But in your summary, I want you to talk about the 4 different ways we talked about of finding compound probability. And since we're talking about compound probability, you should probably say what that is. So a decent summary would say compound probability is, put that in your own words, and then say some ways of finding compound probability are, and then list those ways out. And then for your last sentence, you can do like a for example, okay, of your choice. You know, for example, the probability of flipping 2 coins and landing on heads both times is, or for example, the probability of getting doubles on dice is, or something like that. So do an example that you saw from the video or make up one of your own. All right, that's pretty much it except for the video. I hope you enjoyed this lesson on probability. Probability is kind of fun. It helps with, you know, carnival games, board games, gambling, things like that, the lottery. It helps us understand those kind of things more. Okay, so video time if you're interested in watching a video. It's a brain pop, spoiler alert.
Ha. Stop trying to bend the rules. Dear Tim and Moby, I'm playing the same game you are. What's the probability that I land on a yellow or on a 3? From Gabby. That's a little strange. Yeah, I know. Well, the question involves probability, the odds of something or things taking place. In this case, we're talking about compound events, the combined probability of 2 or more events. Our 2 events are landing on a yellow and landing on a 3. The 3 is on blue, so the spinner can't land on yellow and 3 at once. That means spinning a 3 and spinning yellow are mutually exclusive events. The probability of the spinner landing on yellow or a 3 is equal to the probability of it landing on a yellow plus the probability of it landing on a 3. There are 6 possible outcomes each time we spin, and 2 of them are yellow. So the probability that we'll land on yellow is 2 in 6, which can be simplified to 1 out of 3. There's only 1 3 on this spinner, so the probability of spinning a 3 is 1 in 6, 1/6. Let's plug that into our formula. So the probability of the spinner landing on yellow or a 3 is 2 out of 6 plus 1 in 6. That's 3 out of 6, which can be simplified to 1/2. See? 3 out of 6. Good question. What about the spinner landing on a blue or a 3? Well, that's a different story. The 3 is on a blue piece, so it's possible to spin a 3 and spin a blue on the same spin. That makes them inclusive events. This is a little tricky, so pay attention. The probability of spinning a 3 or a blue is equal to the probability of spinning a 3 plus the probability of spinning a blue minus the probability of spinning a blue and a 3 at the same time. We already know that the probability of spinning a 3 is 1 out of 6. And the probability of spinning a blue is the same as it was for yellow. That's 2 out of 6. So the probability of spinning a blue plus the probability of spinning a 3 is 3 out of 6. The blue 3 gets counted twice, once for being a 3 and once for being blue. This is because the events are inclusive. Right, then we have to subtract the probability of both events happening. In other words, the probability of landing on both a blue and a 3 at the same time. There's 1 blue 3 on the board, so there is a 1 in 6 chance of the spinner landing on it. The probability of the spinner landing on blue or a 3 is 2 in 6. That reduces to 1 in 3, or 1/3. Ready for me to finish beating you at this game, Moby? A tie, but I was winning.
Poor sport. Okay, well, I hope you enjoyed that lesson and stay safe and healthy and keep learning. Bye.